So let's separate the two challenges. There's the infrastructure challenge and there is the cost challenge. On the infrastructure side, I think hydrogen will be not moved directly as hydrogen, but has to be converted into something. So hydrogen can become ammonia, can become methanol, or can become ENG, e-methane. These are the three types of hydrogen. So you can have different colors of hydrogen. It can be blue, it can be pink, it can be green, it can be black, but hydrogen is always H2. And then in order to move it, because it's very difficult to liquefy the pure hydrogen, and to your point, there's no infrastructure. So even if I arrive in Germany with a ship full of hydrogen, no one knows what to do with it. So it has to be ammonia, has to be methanol, has to be ENG. We believe in ENG because that's natural gas. So then you use all the existing infrastructure. The same pipelines, the same power plants, the same steel plants, the same trucks, the same ships. There are ships around the world that are already fueled by LNG. So you have solved the infrastructure problem. Then let's talk about costs. Today, we can make green hydrogen at about 50 euros per megawatt hour, using the technologies that we can buy today, delivered in 3 to 4 years. So that's what we can do where it's very cheap to make solar energy. So if you have solar energy at 10 euros per megawatt hour, you can make green hydrogen at 50. And 50 today is cheaper than natural gas in Europe. So when you look at cost, you really need to look at what the price is to the consumer. Because if I'm in Qatar that has a lot of natural gas, the cost of making the gas is very low. Say 2 euros per megawatt hour, 5 euros per megawatt hour. But that gas is sold in Europe now and Japan and Korea at 60 euros per megawatt hour. So the cost is today around 50, 60. Then you have the subsidies. So with subsidies, the cost will go down. But then the technology curve means that we will get very soon to a cost of green hydrogen at $25 per megawatt hour. This is very cheap.